Hey everybody, welcome back to class. And today the lecture is about smoke evac and some other related systems. So the main class is MEP, mechanical, electrical, plumbing, and I couldn't think of anything that had more interface coordination than a smoke evac system. And it wasn't that I found in the book really anywhere. So this isn't something that I think easily found as far as information. In fact, when I was trying to Google some things, it was more difficult to find some of this info. So hopefully my lecture is clear enough that you have a pretty good picture of what's going on. But we'll start with like I always try to do, show where we're at in the drawings. So on this set of drawings, let's zoom out a bit. We're looking at S.J. Quinney. I didn't work on this project, but this was a good set of drawings for this kind of stuff. And I did have worked on projects with smoke evac before, but I really like this set of drawings. They did a good job and has a lot of info in it. So they're a good set of drawings to bring up in class and stuff. So let's look at this for a second. So we're 437 pages of drawings. Anyways, I didn't look at how many drawings were in the specs, but we'll go up to the front and show you a couple things. So notice that the deferred submittals list. So we're on the second page. Remember the second page of drawings. Try and pay attention to this for deferred submittals. You got the sheet index, some code analysis stuff, the abbreviations, the legends, and then deferred submittals. What's a deferred submittal? You guys think through it. We've talked about it a couple times, especially when we did fire alarm, fire protection, fire suppression. This Division 21. Well, right above that, smoke evac is a deferred submittal. And so the smoke evacuation drawings are, at least in the drawings right now that we're going to look at, they're not complete. So some designers are going to have to finish that off. If we're pretending like we're the general contractor, we're going to have to either find a company that has that kind of a designer in-house, or a company that has partnered with a designer, or maybe we're going to have to hire a designer and we're going to have to hire a company to do this work as well. But there's multiple trades involved in smoke evac, so I think there's enough information in the drawings here to be able to get a pretty good idea of who's got what scope. But anyways, just know deferred submittals and has to be the design has to be completed, and it'd be a whole submittal process to the designer, then back probably to the city. In this case, this is the DFCM project, so I'm not sure exactly how the deferred submittals went, but I would assume it went back through the state of Utah for review rather than a city for jurisdictional inspection. Okay, so we're talking smoke evac. And I found this little video online that I thought was worthwhile that kind of shows what's going on. Let me see if I can find it again. Yeah, this is a good enough one right here. Maybe. This guy right here, even though he's speaking a British language, he does a good job explaining what's going on.
Also an opportunity for the spread of smoke and fire throughout a building.
So we've got an atrium.
To ensure proper smoke evacuation, make-up air must be provided typically by mechanical means at the base of the shaft or atrium. Building codes require mechanical smoke control systems and provide a prescriptive formula for sizing these systems that is extremely conservative, typically resulting in oversized systems with considerable make-up air openings compromising the building's aesthetics. The code also allows for a performance-based design whereby computer modeling more accurately predicts the actual smoke movement in the building,
pretty cool,
resulting in a requirement for less airflow and smaller equipment. The performance-based design process.
Okay, the idea here is that we have some sort of atrium, something that feeds more than two floors that are exposed. So like stairs are in there, or You have an atrium that goes up all the way, and it's not outdoors, so it's all indoors, and each level's accessible from, or you can see down into this atrium, right? And the idea is that if smoke goes off, they try and evacuate the smoke. And in this picture, they're showing the makeup air. So this big exhaust fan up on the roof up here in this scenario is sitting there, uh, pulling out tons and tons of air, and they're saying makeup air. You guys should know that term. So the makeup air in this case is coming from maybe the sides of the buildings or the doors or something, but it needs a lot of air, fresh air from the outside. So makeup air is from the outside, right? It's like outside air, but makeup air is a little different, but not really actually, kind of the same. Anyway, sorry I'm being confusing on makeup air versus outside air, but maybe there's some nuances there if we got into the details. Okay, so kind of get an idea there. Let's look at Google Earth, and we're looking at Weber State's building. Let me go zoom in on their roof, and let me show you where we're at. We're at the Davis campus. Um, I think this is where the CMT program is right now. And check that out. Those two big fans on the roof, those are exhaust fans specifically for um, this atrium right here, and that is smoke evac. That is the smoke evac fans for, and they're the dedicated smoke evac. Kind of see where this one is. This one's like ducted over to here, and this one's, you don't really see where it's ducted over to, but it's a pretty good size opening. If you ever go look on the inside of the building in this atrium right here, go in the front doors in the same building that CMT is, and look up. Go in the building and look up to your left. You'll see these louvers right up here. They're pretty good size up at the roof, and those louvers are connected to this guy right here. So let's look at back to Quinny for a second and go look at their drawings for this. So I thought this was a kind of a good diagram, and I'm going to show you the diagram first, and let's read through. Let's split our screen a little bit here, and we will look at both that and this, and we don't need this thing right now. So we're on the same page, this drawing, that. I'm just zoomed in on the smoke control function matrix. So the smoke control function matrix, and uh, this is the, looks like to me, the point to point list. But let's just actually just zoom in on this diagram of the building. And so we've got this building, SEF, SEF, SEF. So we've got SEF 1, 2, and 3. So those are smoke exhaust fans. That's schematic in nature, right? So it's not really showing exactly what they look like. We got the smoke exhaust fan, SMD, 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 smoke uh, motorized damper, I believe was what the SMD stands for. But it's a motorized damper for sure. So I'm assuming that the MD is motorized damper, smoke motorized damper. So these dampers are going to open, the exhaust fan is going to turn on, and then its makeup air is going to come by these doors right here. All these doors are going to come open automatically because there's going to be a bunch of air cruising through this space right here, through this atrium and out these exhaust fans, and they need air to come back in, and so all of these doors have to open up. And let's start with I'll go to the doors, but let's yeah, maybe we should start on the doors. Doors are easy. Let's just look at that for a second. So we have a pneumatic door kit here that I was looking at, just trying to find one online that was easy to explain. And I think this is an easy one to explain because you see like the handicapped or ADA accessible door opener buttons that are right here and here. Well, when you push on those on the side of a building, there's multiple ways that it opens up. Some are electric, but super common to have these pneumatic ones in it, where a lot of times it's just this little guy up in the ceiling above the door opener, Sometimes there's a big heavy box there. Sometimes they're a little bit better concealed. But you'll see something like this, a big heavy cover, and that guy is pneumatically controlling opening this door. And so there's tubing going from this box, which is above the ceiling, and then it's got a little compressor in it and power, right? So they've got a little 110-volt outlet that needs to plug into, but it's only 12 volts, so it could theoretically be powered low voltage wise. And then anyway, so this guy is getting a signal from one of these push buttons saying open, and so it powers up this little compressor, and the compressor feeds air into the pneumatics right here through this white tubing, and the white tubing pneumatic, meaning air pressure, opens up the door. Now I've seen it where you have multiple doors, and this isn't enough, so they get a little compressor up in the ceiling space, or they go put it in the mechanical space, or they could go put a air compressor in the mechanical room and then run air lines to all of these things. So lots of different ways to do it, and again, from electricity all the way to pneumatics. And I think pneumatics is good in that it's not really providing, other than a control signal, it's not providing building power, so you don't have to put this on. You wouldn't have to run this from a generator, is what I'm trying to say. I don't think if you had it on pneumatics, because pneumatic can be charged in advance, right? You could be having a compressor with lines on it that are all charged, and all you need is a little activation from a solenoid to say open. So let's so we started on what I think is the easiest, and I think anybody who's walked up to a building and seen the automation of the doors opening, right? So got that idea, right? So going back to Bluebeam, one of the things that's going to happen when this system gets kicked on is that the doors will open, the fans will turn on, the motorized dampers will open up, and that's what it's looking at in this smoke control function matrix right here. Is what is happening. So we've got the display, and the device is over here. So the water flow at riser. So that's the um, help me, my brain. I want to call it the flow meter, but for some reason I'm off on that. I think it is the flow meter. I can't think of it. Anyway, there's a flapper in the riser on the fire sprinkler, so that if the fire alarm realizes that there's water flowing in a sprinkler pipe, that means a head is broken, and then it's going to do what? Smoke control panel display, enable smoke management fans. So it's enable means these fans are all going to turn on. Open doors, typical of 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's individual doors, it looks like. And then open the smoke management dampers. Oh, smoke management dampers. I thought motorized dampers, but SMD, typical of 6. So there's the SMD, smoke management dampers. 1, 2, 3, 4, 5, 6. But they're motorized for sure. Maybe they're done something some other way. Maybe they're more mechanical than I'm thinking. Close the smoke damper, fire smoke damper. So we'll come back to this one. Energize SEF1, SEF2, SEF3, and stop AH1, 2, and 3. So what's going on here? We're saying energize the smoke exhaust fan number 1 and 2 and 3. So these all turn on. This all opens. All the doors open. So we're getting air kind of going. Let's draw it. Air's coming in here. Coming in through the door. Coming up. Out the... like that, right? So that's sort of the airflow over here. The air is coming in these doors over towards that, and we've got air coming in this door, and it's just pulling all the smoke right out of this place and into out these smoke enabled smoke management fan, smoke management dampers and out the smoke management fans, smoke exhaust fans. All right, so we've got this close the fire damper, and I'm going to come back to that in a second. I hope you see what's going on here. Um, the only thing that doesn't do all that, it looks like, is if the smoke management fault is tripped, or if the smoke management door opener fault is switched. So if there's a fault in the fans, or if there's a fault in a door opener, it doesn't do all that other stuff, but manual control can do it. An area smoke detector can set it off. So if there's a area smoke detector in the, I imagine it's these right here, any of those will set this whole system off. So let's look at this where was I? I was on the smoke damper, fire smoke damper. We didn't talk about this in the in the ductwork at all. So, but I think it's worthwhile showing. So let's get rid of this guy, and we will go to. I already marked it up. Come on, mouse. Here we go. So this is the atrium right here. Here's the open atrium area, right? So this is the area that is open to below. And what they want, this is, I'm pretty sure, I mean, this whole space right here is open, right? So they don't want a fire from this space to get over to here or smoke to fill up this atrium. And they don't want smoke to go into here and then over into this space, right? And what is this thing right here? That's an 8 on M511. So let's look at that. M on 8511. It's an air transfer, but I want to show you. Okay, there we go. 8. Okay, there we go. It's a transfer air duct, plenum to plenum. So it's above the ceiling. We have the ceiling line here. We have a wall here. And remember, the ceiling is perforated. It's like those, it's like typical office building ceiling, right? Where the above the ceiling is a plenum. You don't, and it's not drywall, right? It's that acoustical ceiling. And so air can transfer up into here, come into here, and go into the next space, right? So they don't have to have a return air ductwork in this room because they'll just put the return air ductwork on this side and it'll just pull air from this room too, right? Over into this plenum. But the idea here is they don't want the fan to be running and be able to pull smoke through this and into this space. So this is an open space between the two rooms. And so what do we put? What do they put on that? Let's go back. They put a, come on. They put a fire smoke damper. Fire smoke damper here, fire smoke damper there. Probably one over here too. Yeah, there it is. So there's a set of doors right here. If you cannot not follow what we're seeing, right? We have the atrium here, you have doors, and this whole space right here is sort of like the elevator stair lobby idea, right? So have all this area right here. I bet you could find more if we went into find these other doors. Yep, there's another door with a ductwork smoke damper there. Let's see if there's any other doors that have somewhere over here. I'm surprised they're not. Oh, there it is, our smoke damper. Okay, so all the ductwork leaving this open commons area because it's the walls lining this open commons area, even one right there. They're all fire rated, right? It's supposed to be protecting this area right here, and the smoke evac is protecting that area. And this area is stacked, right, up vertically. You don't have the model to show you, but there's a smoke damper there, smoke damper there. Let's see if we could find that smoke damper. I don't think that detail showed a whole lot, but we'll do it anyways. And yeah, it doesn't really show a whole lot. Fire smoke damper. Anyway, the idea is that it'll just close off that duct, okay? It's just really showing turning vanes is all. It's like these dampers that are just individually, they're all open like this, and then they're going to turn and shut like that, right? So there's a whole bunch of them in a row. These damper, and then as they rotate, they make it so no air can go this way. Hopefully that made sense. Just a damper, and it's just like any kind of damper. They use the dampers to adjust how much air is going through a room. Like remember if we were doing that VAV box. The VAV is variable volume, and inside that box there's a little circular damper that was motorized to control, like had this little thing that opened and closed to be able to control how much air is going into the duct. Same kind of thing. This is just going to either be open or closed. That's all this damper is going to do. And so they're going to have a damper, smoke control damper, that's controlled. That when the smoke evac system is tripped, definitely this fire smoke damper is closed. This one's closed. That one's closed. They all close. And so going back to what else that thing does, what else did it do? It stops the air handler 1, 2, and 3. So all the air handlers stop running, stop putting air into the room. Why do they not want the air handlers to run? Well, going back to this space, remember, I don't know what all this building was as far as HVAC. I don't remember. But an air handler is going to get some return air on it, right? And so they do not want to pull smoke or hot gases or whatever from one space into the ductwork, which would allow it to transfer to another location, right? Or so they're going to shut down those air handlers, and they also don't want to supply new air into a space that's on fire for more oxygen. So shutting the smoke dampers and shutting off the air handler is a good idea because all they're going to do is going to try and make sure this atrium space is kept free of smoke. All right. Well, you might say, what happens if the power goes out on the building? But check this out. You guys have seen this before, one of these before. Well, power one line diagram, okay? And we're saying this is the lightning protection, ground bus, blah blah blah. Main switchboard. Okay, so here's our main switchboard. Uh, it doesn't matter. This is a big building, and so there's a lot of power feeding it. We're seeing all this distribution of power. And if we really wanted to dive in, it wouldn't be hard. We could figure it out. We could trace it all out. But all I'm trying to separate is two things. All this stuff up here, and then, so this is the main distribution from the utility or whatever. And then we've got an emergency standby generator. So we've got this emergency standby generator that is feeding a couple things. Follow where this goes. These two lines right here. It was that line and that line. And so we're going to the ATS. What's an ATS? Automatic transfer switch. Normally the power is coming through right here to this whole bunch of it looks like another panel with feeding a bunch of equipment. So this IQHDPA is this panel right here. And whatever, they just, I have no idea why they named it that, but this panel right here is being fed by two sources. One is the utility source, and then is also the standby generator. And check out what is on there. SEF, SEF, SEF. So all of the panel that feeds the exhaust fans, the smoke exhaust fans, they're not only powered by the main, they're also back on the generator power. When the generator kicks on, this will be on as well as the elevators and 1QHM, 3QHA, 5QHA. These are three different panels, and we'd have to go look and see what those panels are, see what they're providing power to. I assume lighting, maybe something else. I'm not sure. It says this one's mechanical standby power, standby power, standby power. So we'd have to see what IQH, and that's not what we're trying to do. Is all I was really trying to show was that the power for um, the smoke evac fans is on backed up by the generator, and so we've got this whole building here that has got smoke exhaust fans and the doors opening. And then let's look at some more of the options that might happen as well. And I got a couple. This is also something that might happen. So we've got this guy doing a little smoke test. He's got his little smoke in a can right there, throwing it on a smoke detector. Notice he's not just jamming it full of smoke. He's just giving it a little bit. Ooh, the door just closed. Why did the door just close? Let's try and go really close to that. Right. Do extra slow here. Ooh, see that right there? There's a magnetic door holder. Door holder. So the door. Um, oh, you know what? I don't know if I ever. Let's Google. I don't think I left one open. Yeah, I don't think I left one open. Yeah, they're these right here. I think he's. Hey, I'm acting like it's super simple, but sorry, this is not very hard. This thing's mounted to the wall. That is mounted to the door. This is receiving uh, some low voltage power, and it's connected to the smoke evac system or the fire department's fire alarm system. Some sort of fire smoke controller. I'm not sure which panel it is going to be. I'd have to see what open up the drawings. But anyways, this thing is energized, and when it's energized, it's got power going to it, which is holding this little metal piece to that right there. And when it's not energized, it just releases its magnetic hold, and the door's shut. So it looks just like this when this is kind of a bad video, but couldn't find another one on YouTube. Like I said, when I started Googling this stuff, it was kind of hard to uh, find examples of this. Oh, the smoke detector just read it. You see the lights went off. He's like, oh, hey. Door holder was released, that magnetic door holder. And the door has been shut. And now he's going to go cruise over. We're going to watch his, uh, watch him walk all the way over to. What's he looking at now? What is that? Some sort of fire control panel. Not sure who made it or what system it is. He silenced it. I'm tired of listening to it. I don't know. Let's see if it can be seen normally. Alarm, smoke, corridor, AC. Why? Because that was addressable. That was fire doors. Those are. He's going to show what was affected. That smoke detector by that fire door. Absolutely. That's anyway, kind of cool stuff. So that's one thing that could have happened in the situation. Here's another example of it. You see the little door holders right there. Kind of cool. We've got these that could go down potentially. These are the smoke and draft control assembly. I think they're usually referred to as smoke curtains, I think is the term. Yeah, smoke curtain. Anyway, that's something that could pop down from the ceiling and go. It just depends on how the design is done. So, um, in the building we were in, that we were just looking at, I think it's on this sheet. I don't know if they've got them or not. We could go try and find them. Let's see if we have them on any of the floors from the architect. Or we could just smoke. We'll search smoke curtain. Hey, so recording this lecture while I'm normally I try and use the room and shut the door, but just felt like being more open today, and so you can actually hear my kids talking. I don't know if you can or not. B5 and 620. 1404. I didn't see it. It doesn't look like it. And I didn't think this one had it, but it could be wrong. He's not showing it here. And I don't think it's there because I believe this whole elevator uh, is enclosed. I didn't think you had to do it when. But if these doors were all open and there was no way to like enclose this elevator room, um, anyway, I don't know. I'm not a code expert on when you put a smoke thing in or not. But I did want to show you that that's something else that could be going on. These smoke curtains could be dropping. Here's a bunch of different versions of the smoke curtain. That one could go down. That one could go. I found a good version of that online. So it was actually this one right here that I first started with. Check this out. They're dumping a ton of smoke into this atrium out location, and eventually the fire alarms, smoke control is going to take over and do some work. Well, fire alarm just went off. It looks like to me they got like these smoke machines sitting there and some you guys got a smoke here. Not able to trip what he needs to trip. Come on. I want it to trip. Trip it. I've had that before where the smoke we bought is the smoke detectors are smart enough to know that that's not real smoke. Now it's really going. There you go. So all those smoke curtains are coming down. Protect all those corridors. So some other things that it might be doing, and I didn't bother to look and see if they had it on this stair. Let's look at this stair here, though. We'll go back to so sometimes they'll pressurize these stairways as well, and they'll be like a supply fan, basically a complete by itself makeup air fan, just pumping tons of air into this stairwell to keep it pressurized so that anybody coming in one of these doors. Oh man, my kids are. Sorry, I'm back. My kid was mad that the other kid was trying to steal his M&Ms. Whatever. Uh, and I almost feel like editing that out, but that's life when we're not sitting there in class. So it is what it is. Anyways, I was talking about this stairway being pressurized, and that's something that is potentially part of this whole system to be able to pressurize certain stairwells. All right, the last thing I want to talk about is the actual testing of this system and coordination of the test prior and coordination of the system prior to the test. So let's just run through, kind of get how many trades were involved, and I'm going to post this website here, this white paper written by Mark Meekum, and he explains control systems, this smoke control system well, and some of the codes involved, and then he gets into this part right here that I think is really, really, really good: the benefits of a test plan and making sure we have a functional matrix prepared in advance. And so he's our we're looking at that matrix, the functional matrix, um, but we could get really detailed. And I used this matrix the last time I did help work on one of these. Anyway, the value of having a test plan is super super good here, and trying to coordinate that. So let's just jump back into this for a second. Here's our matrix, functional matrix. And so we need a test plan based off this, and just kind of run through this for a second. We've got water flow at the riser, meaning we've got the the fire sprinkler guy involved. We've got fire alarm here involved. So those are two different trades, potentially three, depending on how those contracts are all set up. Sometimes the person doing the fire alarm is not actually the person doing all the it is not the same company as doing all the wiring for the fire alarm and all the devices sometimes it's just a company coming, landing all those wires, programming the fire alarm panel and moving on, or the smoke control panel. So anyways, paying attention to how that's going to work. We've got the smoke management fans, right? So who's that? That's probably our mechanical contractor. Open doors. Well, that's somebody we haven't really talked a lot about as far as coordination and interface, but now we got the potential to have a completely different trade that's not usually involved in MEP, now involved in making this system work. How do the doors and the openers they provide going to work with the system? So we've got that trade. Smoke management dampers, we already talked about that. That's the mechanical contractor. Fire smoke dampers, and we've that's mechanical as well. But who's going to wire and control it? That's a good question. I don't know. I don't know if it's going through the fire alarm or if it's going through the BMS, the building management system. I don't know that. That's a good question. Off my head, I don't know who actually controls smoke dampers. It might be, but it might be directly by the fire alarm. I'm not sure. Okay, so anyways, we've got the exhaust fans as well that we were just talking about, and then we got to stop the air handler. So we've got some controls, mechanical contractor, uh, all of that involved in trying to get this to work here. So that's a fair number of trades, right? And so reading through this gentleman's white paper on actual fire smoke systems, I thought it was very very good, and I'm really glad he brought up the benefits of a test plan. Um, Really good to try and have a good idea up front who's doing what and how we're going to get through the different elements. So the last time we did one of these, we tested individual components, uh, smaller systems by themselves, right? So for instance, we would test out individual doors, make sure all the doors were working, then run all the doors at once, see if they opened up all at once. Yes, they all opened up. Okay, if they're all opening up, let's leave them all open and let's test the motorized dampers all individually, and then we're going to test them all as a group because they're all supposed to open. Then we're going to test. Okay, we've got those to work. Let's try and put this in sequence. Let's do doors, dampers, and exhaust fans. Okay, we got all that. Those are all working really well. In fact, prior to doing any of that, we probably have to turn and bump each individual motor on all these fans, make sure that they're running individually, and then move to the next stage. Now we've got these smoke that need to be involved. So we've got a bunch of layering is maybe a good way to describe it. Bunch of layering to testing, where we're testing out smaller systems and components, getting ready for the entire system to work in one go, so that when we're in front of the fire marshal or other jurisdiction having authority, that go and simulate the smoke in this area, that the entire system is now automation is just working, right? So it's all just going, and that doesn't happen all at once. It's a series of coordinations. It's a series of doing testing to make sure certain things are working. And like I said, all that layering effect. This is working now. This is working now. That's working now. That's working now. We can try and put multiple systems together and test them out, pre-functional test them, and then move on to the more final tests where we're simulating real, like they were doing in those YouTube videos that I was showing. And some more stuff I didn't even bring up was the like when we looked at this matrix, this building doesn't have any of those smoke curtains. Um, so smoke curtains could be a part of it. The we didn't on this matrix right here. They don't have the stair towers, exhaust fans, but that could be in that kind of a building. So they might have that system all tied in, and lots of different things that could be tied in toward to this system. This matrix could end up being pretty long of all the things that are tied into it. In fact, this is a fairly short smoke control matrix here, so fairly simple. But it could get fairly complicated with even more trades going on here. Pretty cool stuff. Hope you enjoyed that lecture, and we'll talk to you in the next class.